Okay, characteristics of polynomial functions in factored form. What can we gather from this? Let's see. Family of polynomial functions is a set of polynomial functions whose equations have the same degree and whose graphs have common characteristics. So first of all, the important part is they must have the same degree. They don't have the same degree, they don't even belong to the same family. Next, you got to look at other characteristics such as the zeros, maybe the stretch and compress factor, things like that. So, order is the exponent to which each factor in an algebraic expression is raised. For example, if you're looking at a function like this, you're looking at x minus 3 has an exponent 2. So this will have order 2. X minus 1 has an exponent of 1 here, so that is known as order 1. Total, this is a cubic function because there's x squared here and 1x here. Together, that makes x cubed. So this represents a cubic function. Next, the zeros of the polynomial function f at x are the same as the roots, or the x-intercepts of the related polynomial equation. So that means f at x equals 0, and that means that when f at x equals 0, these will be the values over here. Now I want you to look at this particular function here. How do you know without looking at the equation? So imagine I didn't have the equation here. Let's go back a little bit just so that you can understand this question. So I'm going to look at this function. Let's try and determine the degree by looking at this function. Are you ready? So we can see that this function opens upwards. So we can see there's going to be a positive leading coefficient because they're both moving upwards. So what we're looking at is there. Those end behaviors are upwards. So it's positive leading coefficient. Also, we know it has to be an even degree polynomial. So let's figure out how many degrees it could be. Well, it has 1, 2, 3 turning points. So the 3 turning points here, again, 1, 2, 3, means that it has to be higher than 3. So let's say 4. And then how many zeros does it have? 1, 2, 3, 4. And so that looks like that they're going to be a degree of 4, this particular function. It's a positive function and it's even. Why would it be 4? Now, what's more important than how do I know it's going to be 4 is look at each zero. Look very carefully. So what we're going to do is I'm going to grab this for a second and I'm going to erase all those lines that I did here, and I'm going to grab the actual graph and we're going to make it a little bit larger so you can see what I'm looking at. If you look very carefully at these zeros in particular, you're going to see that the zeros, oops, let's look at it again. There we go. We're going to look at the zeros, and can we see that the zeros, as I make this larger and larger, well, I'm going to look specifically at the zeros. So right here, this function here looks like there would be a line going through this zero. And over here, there's another line going through that zero. Another line going over here, and another line going through here. So going through each zero, it almost looks like if I was to make this larger and larger, it looks like it is seriously a line going through each of these zeros. So what we're looking at is a linear function at each one. So what this means is in our case, the question would have each of these zeros would have an order of 1. So each zero will have x-intercept has an order 1. Order 1 because each of those x-intercepts looks like the graph looks like a line if we were to do a close-up of it. So let's look at another example. So this would be even degree polynomial, probably I would say at least a quartic. And we definitely know it should be a quartic because each of these has order 1. Each of these zeros has order 1. There are 4 zeros with order 1, so we're looking at a quartic. Now, what happens if you have let's go back to that first one. All right, you have this. What could this be? Well, this would have to be odd. It would have to be odd because the arrows are pointing in opposite directions. We also know that these arrows connected would represent a positive leading coefficient. We also know something different over here. This one looks like it's passing like a line. So we know this one will have order 1. Over here, this one looks like this area is passing like a quadratic. So that will have order 2. Now the question becomes, how do we figure out this 1/10? Well, folks, in a question, I would give you definitely the zeros, you'd be able to read it, and you'd be given 1 point. You'll be definitely defined which point you'll be given. Okay, so you won't have to guess. So an example that would work well over here is we would have to find a nice point. I don't see any really nice points over here. Maybe this one about half. But you will be given a point with a dot on it to know that that's the point I'm referring to. All right, let's try another one. What about this graph? What can you tell me about this graph? Without looking at the equation, what can you tell me? Well, look at the arrows both pointing upwards, so the leading coefficient is positive. We also know there's something weird going at this 0. What's going on here? Well, it looks like there's a cubic thing going on over here. So it looks like there's a cubic function happening around the 0. That means that this 0 will have order 3. And this 0 over here has to have order 1 because it looks like it's a line. And if you look up here, that's what the equation talks about. And then you would substitute another point to find the 1/5, the A value. All right. And next one. So here we go. We're looking at this and we're trying to match the equations with the graphs. Which ones go with which? Looking at the first one, you can see that you have 2x plus 1 squared times x minus 3. So there has to be a parabola around this root and a line around this root. So how are we looking at it? So over here we have around -1, we should have a parabola going on, and around 3 we have a line going on. We also know that the leading coefficient here is positive. So the only two possible questions that would represent a cubic are these two. This one has a positive leading coefficient. Looking at the end points, this is the only one that represents a positive leading coefficient. So A matches with this graph over here. B, we know that at -1 it should be squared. That means there should be a parabola at -1. And we know at 3 there should be another parabola at 3. So which one has a parabola at 1 and 3? Well, that would be this one with a positive leading coefficient. There we go. So B matches with graph A. Part C, you have this going on. So what is this? Well, negative leading coefficient, and you have x plus 1 and x minus 3 all squared. So at -1 is 1, meaning there should be a line at -1, and at 3 it should be squared. So at 1 there's a line, but here there's a 0. Oh, that one doesn't work. Let's try this one. 1, there's a -1, there's a line, and at 3 there's a parabola. So we're good here. And it's an odd power with a negative leading coefficient. So if we connect those two endpoints, we would see that we would have a negative slope. So therefore, that matches with graph B. And the last one, D, matches with D. But specifically, let's look why. All right, so what are the zeros? The first one over here, x by itself, means that x has a possibility of being 0. X is a 0. So that means that that is this point right there. The next one is -1. That's this point right here. The next one is x minus 3, which means that x value 3 is there. And the last one should be 5. So this represents a quartic that crosses the x-axis 4 times with 3 turning points. All right, that's the end of the lesson, folks. Take care. Have a good night.